We're on page 2 now. There's a little hint here about these numerical exercises, and we're doing these square roots separately from cube roots, etc. So if you see the number under the radical sign, we call that number the radicand, by the way. That's the fancy math word. Take the radicand, and if it's not a perfect square, try dividing it by 2. And after you do that division, like 18 divided by 2 is 9. See the other number we got, the quotient we got, 9, that is a perfect square. If we divide the number by 2, like divide this by 2, you get 24. 24 is not a perfect square. But then try dividing by 3. 48 divided by 3 is 16. 16 is a perfect square. So the little strategy here is, if it's not a perfect square that you're presented with, try dividing by 2 and then by 3 and then by 4, etc. Eventually you're going to get a quotient, an answer that is a perfect square, unless it's, an example where it cannot be simplified. So 8's not a perfect square, but 8 divided by 2 is 4. 4 is a perfect square. There's my clue as to how to break this up, how to factor it, I could say. 8 is the same as 4 times 2. Why are we doing it like this? Why are we rewriting that? Because this is a perfect square. I can change that to an ordinary number 2. Square root 8 is equivalent to square root 2. Square root is considered simplified when you've made the number under the bracket called the radicand, when you've made the radicand as small as possible. Oh, moving over here. 18 is not a perfect square. 18 divided by 2 is 9. 9 is a perfect square, so I'll break that up like so. 9 times 2. This changes to its exact equivalent, a plain old number 3. So, square root 18 is the same as 3 times the square root of 2. And by the way, if you punch that into the calculator, you're going to get a decimal, 4 point something. If you do 3 times square root 2 with the calculator, you should get exactly the same decimal. That is one way you could check your answer. Oh, 75 is not even divisible by 2. We'd get a decimal. 75 divided by 3 is 25. And 25 is a helpful result here because that's a perfect square. That's the square of 5. That becomes 5 times square root 3. Square root of 75 is the same as 5 times square root 3. And here's this one. Divide by 2, you get 24. That's no help. Divide by 3, you get 16. So there's 48 factored into 16 times 3. 16 is a perfect square. It's the square of 4. So we get 4 square root 3. Okay. Hope I'm not going too fast. Is 98. 98 divided by 2 is 49. Very nice. 49 is a perfect square. That becomes a 7. So it's 7 square root 2. Okay. What do we do if there's a coefficient like this? Just keep it. Don't lose it. This is going to be 5 times. Now, how are we going to break up the 20? If we divide 20 by 2, we get 10. 10 is not a perfect square. You can't divide it by 3. Divide it by 4, and you get 5. 5 is not a perfect square, but the thing we divided by 4 is. 20 factors into 4 times 5. Square root of 4 is exactly 2. So this becomes 5 times 2 times square root 5. And we're not going to leave this as 5 times 2. We'll change it to a 10. So 5 times the square root of 20 is exactly the same value as 10 times the square root of 5. And again, this is considered simplified because we've made the radicand, the stuff under the radical, as small as possible. Now for cube roots, remember here's your list of your first several perfect cubes, 1 to the third, 2 to the third, and so on. Okay, 8 to the third, 9 to the third. 16 is not a perfect cube. If we try dividing it by 2, same strategy as we used for squares, divide until you get a perfect cube. 16 divided by 2 is 8. 8 is a perfect cube. We will factor this like so. And the cube root of 8 is exactly 2. So I write 2. And notice I'm being very careful to get that index in there so nobody thinks I mean 2 to the third power. I mean 2 times the cube root of 2. That's the exact equivalent of the cube root of 16. Okay? One more, and then we'll end this video for page 2. Cube root of 250. 250 is not on the list up here. Divide by 2, you get 125. So we rewrite this, cube root 125. Cube root 2. See, there's 250 factored. And why are we using this? Because that's the cube of 5. That is a perfect cube number. Cube root of 125 is exactly 5. Our answer is 5 times the cube root of 2. Cube root of 250 is exactly 5 times the cube root of 2. That concludes page 2 and video number 2.